Okay, picking up at number 4, which points on the graph of y equals 4 minus x squared are closest to the point 0, 2? So let's look at the graph. You have 4 minus x squared, so that looks like this, are closest to the point 0, 2. So it's deciding which is closest. So this is a distance, right? A distance like this. So if we draw a triangle, so this would be x squared plus y, but that's not really y, so hang on. We have x squared plus this right here, so this is 2, so it's really y, which is, I'll do a different color, maybe I'll okay, y is this whole thing, minus 2 gives us just that part that's left. And I know that now that doesn't look like anything, but hopefully you can tell. So x squared plus y minus 2 squared equals the distance squared. And that distance is what you want to minimize. Now, you have y equals 4 minus x squared. That's your secondary equation. So you're going to plug that into your primary equation. So you have, let me go back to black. X squared plus y, which is 4 minus x squared minus 2, all of that squared equals d squared. So, let's see, this is negative x squared plus 2. We're going to square that, so that becomes positive x to the 4th minus 4x squared plus 4, and we have an x squared plus that. So x to the 4th minus 3x squared plus 4 equals d, and then we're going to do the square root of that, so we have d by itself. Yikes, that's what we want to take the derivative of. So the derivative of the inside is 4x cubed minus 6x times the derivative of the outside, which is 1/2 times this whole thing to the negative 1/2. Equals d prime. So, moving up here, that gives us, oh no, take a 2 out, so that's going to be, if you take a 2 out of both of those, so it'll be 2x cubed minus 6x divided by the square root of x to the 4th minus 3x squared plus 4 equals d. Yeah. I am thinking, all right, we can do this. So your numerator equals 0, take out a 2x, you're left with x squared minus 3. So when that equals 0, you'd have 0 or plus or minus root 3. And the bottom, if you set the bottom equal to 0, if you factor that, it is x squared minus 4 and x squared plus 1. So there you would get 2 or negative 2. So you know that the graph is symmetrical, so you really just have to deal with one of them. So we're going to do 0, root 3, and 2. So I'm now going to erase this board. Hopefully you've gotten all this. If not, pause it real quick and write it down if you want it. Otherwise, I'm going to erase this so we can start over. So we have now on our number line 0, root 3, and 2. And I didn't copy down that derivative. So you're on your own from here. Plug in. You want to plug in here and here. Actually, you don't even need to go past that. Just plug in each of those into the derivative and go from there. Got that? Hopefully you can finish that problem on your own. Let me go on to the next one. Okay, a rectangular page is to contain 24 square inches of print. So let's see, we have a regular rectangular page, regular 24 square inches. So this is 24 inches squared in here. The margins at the top and bottom are 1.5 So this is 1.5, this is 1.5, and the left and the right are 1 inch. Which should the dimensions of the page be so that the least amount of paper is used? Okay, so let's let in here be our x and our y. So we know that xy equals 24. Okay, and then the least amount of paper, that's the area of the paper. So let's find our area. Now, this is y plus 1.5 plus 1.5 is y plus 3. So y plus 3. And then this is x plus 1 means this is x plus 2. So times x plus 2. That's the area of the paper that we want to minimize. The least amount of paper is to be used, so we want to minimize that. So xy equals 24, solve for one of them. If we do y equals 24 over x. So we have our area is 24 over x plus 3 times x plus 2, and you need to figure that out, or multiply that out. I would multiply it out. You can use product rule, it's up to you. I'm going to go ahead and multiply it out, so I get 24 plus 48 over x plus 3x plus 6, so that is 30. So 48 over x plus 3x plus 30, area equals that. So now do your derivative. Let's see, that is x to the negative 1, so negative 48 over x to the negative 2, or times x to the negative 2, so over x squared plus 3. Set that equal to 0. So 3 equals 48 over x squared. 3x squared is 48. X squared is 16. So x is plus or minus 4. We don't need the negative 4 because it is a page and it doesn't make sense to have a negative. So if we plug in 3, now we're plugging into our derivative right here. If we plug in 3, that's 9, so that's negative 3 point something plus 3, so that's negative. And if we plug in 5, that ends up being positive, decreasing to increasing, that gives us a negative. A minimum. So when x equals 4. So when x equals 4, and if x equals 4, then y is 6. So the dimensions of our page is x plus 2. So 4 plus 2 is 6 inches by 9 inches. That would give us the minimum amount of paper used. I got 9 by doing y plus 3. All right, so there you go. And I don't know, maybe I'll do one more. Let's see what it is. All right, 4 feet of wire is to be used to form a square and a circle. How much wire should be used for the square and how much should be used for the circle to enclose the maximum area? All right, so we have a square, we have a circle, 4 feet of wire. So 4 feet of wire is our perimeters. So basically, if we call this S, so we have 4S plus, and then this is R, that's 2 pi R equals 4, okay? And then we want to maximize the total area, so area S squared plus pi R squared. What is easier to solve for? I have no idea. Let's solve for R. So we have 4 minus 4s divided by 2 pi equals R. So 2 minus 2s divided by pi. So we have s squared plus pi times 2 minus 2s over pi squared. I don't think that's the easiest. Let's go back. Sorry, I know it's easier for me to erase than you. Let's solve for for S. So if we solve for S, 4S equals 4 minus 2 pi r. So divide by 4, 1 minus pi r over 2. I think that's going to be easiest. So we have s, which is 1 minus pi r over 2 squared plus pi r squared. So, let's use a chain rule when we do the derivative. Not double prime, sorry. So a prime. So the derivative of the inside is negative pi over 2 times derivative of the outside is 2 times 1 minus pi r over 2 plus 2 pi r. So that's negative pi minus plus pi squared r over 2 plus 2 pi r equals 0. Set that equal to 0. So, yeah, this is a pain. Equals 0. So I'm going to stop there and pick this one up. Actually, I think this example is in your book. You could look it up there. Otherwise, I'll stop there and start there next class. Sorry about that. But it's a pain. It's too big to write on just this screen, and that's all I have. So stop there and do your best on the homework, and we will really discuss it next Monday.